Hello, so good day everyone. Welcome back for another video discussion. This is ECE 23 Performance Task. This is yours truly, Mr. Arcabal of BSECE 3C. So for today's video discussion, we're going to discuss all about MC Cdma or Multi-Carrier Code Division Multiple Access. In short, MC Cdma is a relatively new concept. So it is development aimed at improved performance over multipath links. So it is used uh, for multipath links. So MC-CDMA is a modulation method that uses multi-carrier transmission. So it uses multi-carrier. So it uses multi. So it means many or more. More carrier transmission. So more precisely, OFDM of DS-CDMA type signals. So there are many equivalent ways to describe MC-CDMA. So it is a form of CDMA or spread spectrum, but we apply the spreading in the frequency domain rather than in the time domain as in direct sequence CDMA. So MC-CDMA is a form of direct sequence CDMA, but after spreading, a Fourier transform or FFT is performed. MCCDMA is a form of orthogonal frequency division multiplexing or OFDM, but we first apply an orthogonal matrix operation to the user bits. Therefore, MC-CDMA is a sometimes also called CDMA or OFDM. So, MC-CDMA is a combination of CDMA and OFDM. MC-CDMA is a form of direct sequence CDMA, but our code sequence is the Fourier transform of a Walsh-Hadamard sequence. So, MC-CDMA is a form of frequency diversity. Each bit is transmitted simultaneously in parallel on many different subcarriers. Each subcarrier has a constant phase offset. The set of frequency offset form a code to distinguish different users. So, MC-CDMA in short is a multi-carrier code division multiple access. So it uses multi-carrier. So next, so we have here uh, figure of FFT implementation of an MC-CDMA based station, multiplexer, and transmitter. So MC code division multiple access systems allow simultaneous transmission of several such user signals on the same set of subcarrier. In the downlink multiplexer, this can be implemented using an inverse FFT and a code matrix. So shown in this figure, so we have here user signals. So many user signal. It goes through our Walsh-Hadamard code matrix, and after it goes to the inverse Fourier transform or our IFFT, and it goes to parallel to serial, and it goes to the subscriber. So here we have MC CDMA as a special case of DS CDMA. So in this figure, this is a possible implementation of a multi-carrier spread spectrum transmitter. Each bit is transmitted over n different subcarriers. So each subcarrier has its own phase offset determined by the spreading code. So in this figure, we have C here user signal. It is from one user. It goes to serial to parallel and goes through Walsh-Hadamard code vector. So from one user signal, it pass through serial to parallel. So these have n different subcarriers. So n different subcarriers, and it goes to inverse FFT, IFFT, and goes to parallel to serial. So from here, it comes from serial to parallel, and we have our output of parallel to serial and goes to the subscriber. So next we have here the figure of receiver model of MC Cdma. So because of delay spread and frequency dispersion due to multipath fading, subcarriers are received with different amplitudes. An important aspect of the receiver design is how to treat the individual subcarriers depending on their amplitude pi. So the options are linear combining by weighting the ith subscriber by a factor d sub I according to. So we have here maximum ratio combining d sub I is equals to pi. This optimally combats noise but does not exploit interference nulling. So equal gain d sub I is equals to 1. So this is the simplest solution. Equalization d sub I is equals to 1 over pi. This perfectly restores orthogonality and nulls interference but excessively boosts noise. So equalization restores orthogonally and nulls interference but excessively boosts noise. So it have an excessive boost noise. So Wiener filtering. So d sub I is equals to pi all over pi squared plus c. So this gives the best post-combiner signal to noise plus interference ratio. So overall, this is the purpose of the receiver model, and this is the diagram of our receiver model. So next, we have a system model of a coded MC CDMA system. So with K users, assuming perfect frame synchronization is shown. So the information bits of the user is encoded using a convolutional encoder. So the coded bit of the K user at the time interval is then spread by a PN sequence and transmitted using MC-CDMA, where the total number of subcarriers is equal to the length of the signature sequence, L. At the receiver, the channel spans of the subcarriers are independent. The signal of each user is displayed and maximum ratio combining or MRC in a frequency domain is performed. So in this figure, we have seen user bit number 1. It goes to the encoder and after it goes into interleaver, goes to serial to parallel convert. So after it goes to IFFT and from here it goes through our FFT and MRC or maximum ratio combining. So and goes through iterative log map based MUD and decoder. So from an encoder, it goes through and output to a decoder, and this is an output of a received user bits. So this is same also as a user bit number 2 and user bit K. So this is a system model of our coded MC-CDMA. So next, so what are the advantages of MC-CDMA? So compared to DSCDMA, DSCDMA is a method to share spectrum among multiple simultaneous users. Moreover, it can exploit frequency diversity using a rake receiver. However, in a dispersive multipath channel, this DSCDMA with a spread factor n can accommodate n simultaneous users only if highly complex interference cancellation techniques are used. In practice, this is difficult to implement. MC-CDMA can handle n simultaneous users with a good PER using standard receiver techniques. So, MC-CDMA compared to OFDM to avoid excessive bit errors on subcarriers that are in a deep on subcarriers that are in deep fade. OFDM typically applies coding, hence the number of transmitted simultaneously. MC-CDMA replaces this encoder by an NXN matrix operation. Our initial results reveal an improved BER. So this is the advantages of MC-CDMA. So in summary, MC-CDMA is a novel digital modulation and multiple access scheme. So it is a combination of OFDM and CDMA. So it allows the system to support multiple users at the same time over same frequency band. So it support multiple users at the same time over. So it can handle uh, many user at once in the same frequency band. So MCCDMA spreads each user symbol in the frequency domain. So it can handle n simultaneous users with DER. Using standard receiver techniques unlike BSCDMA, which can only accommodate n simultaneously user only. So in a high complex interference and cancellation techniques. So this is all about MC-CDMA. So I hope you have gathered some information about MC-CDMA. So that's all for this video, and thank you.